This is the pre-lab video for a ratio control lab at the Red Deer College. I want to step through kind of the process on this ratio control trainer that we have in front of us. If I move over here to the right, you can see we've got these two copper lines running down, one for hot water and one for cold water. That's what this trainer is going to be doing. It's going to be mixing hot and cold water and controlling the temperature of the mixed stream out. So these two lines, you can see they flow down and over to our trainer. Let's kind of walk back over here just to have a look. The hot water comes in over here and mixes down here, and the cold water comes in down here and then mixes with the hot water. So this is the mixed out. The mixed flows down into this 2-inch PVC pipe and then back over here and down, and the temperature is measured by this transmitter right in the middle, flows down and then exits down into our sump pump and then is discharged out over to a drain over in another part of the building. So let's kind of quickly just look here. We've got two control loops that we compare on this trainer. We have both a feedback and a ratio control loop. It's comparing to see the benefits and to see how ratio compares to a feedback control loop for the same process. So what I have here is page 2 of the lab. We can see we've got our hot and cold water coming in and then our mixed exiting over here. Right here is our feedback control loop, and all of this right here is our ratio control. So we compare the two. We basically disable the feedback control loop, use ratio, and then disable the ratio control loop and use feedback, and compare the two strategies to each other. So let's quickly identify these two loops on the trainer. We've got TIT3, TIC3, and TV01. So TV01 is right up top here. This would be the valve for the feedback loop. TIC03 is in this controller. This Honeywell controller can handle more than one control loop. You can see it also handles FIC. It has an FIC02 and a TIC03. And then the transmitter for the feedback control loop. So this is our valve, this is our controller, and then our transmitter for the feedback loop is this one right here, which is TIT03. You can see right there. So that identifies our feedback control loop. Let's have a quick look now at our ratio control loop. We've got these two flow transmitters, and they have an M there that represents their mag flow meter. We have FIT01, FIT02, we'll need to find those. FIC02, I already kind of identified, it's in that Honeywell controller. And then our valve down here, FV02. So let's kind of point out all of these. We have FFY01, this is a multiplier block, and this is where you're going to be entering your ratio for ratio control. So this will take the flow rate, multiply by the ratio, and figure out a remote set point for FIC02. You'll be doing this all in the lab. So just back over here, you can see our valve for the ratio control is down here on the bottom, FV02, and our two flow transmitters, we've got FIT02 and FIT01, and our multiplier FF01 is going to be in this controller along with FIC02 to figure out a remote set point, give it to FI02, and he's going to try to control the flow down here in the stream, in the cold stream. So there's technically 3 streams here. We've got one with hot water, one with cold water, and then we've got our mixed out. In ratio control, typically this stream up here, the hot water, would be classed as the wild stream. The reason why they would call it the wild stream is because there's no actual control loop on it. If we got rid of the feedback, ignored that, there would actually be no control loop, no valve on here, nothing to control the flow, so it could fluctuate, and that's why it's now termed wild. Down on the bottom here, we have this control loop right here, so we can control the flow. So this would be called the cold water. That stream down here would be called the controlled stream. So we have the wild stream up top, controlled stream on the bottom, and then our mixed stream exiting. So there'll be some questions on the pre-lab questions to answer in regards to the process that we've just went over here for the Ratio Control Lab.